Okay, so this problem, it's in the book on page 662, and they have a nice picture so that if you wanted to look at that, I'm going to attempt to draw a nice picture, but theirs is like all...
When you have a professional artist, sometimes it makes it helps.
Cartoony and whimsical, and it's great. So the idea is that with radio signals and light and all these different things that are waves, you can use hyperbolas, parabolas, and even ellipses have their kind of thing that goes with that. You can use those to model that behavior. So in
the
this
waves
case,
of
the waves of your
the
signal.
light or signal.
Right.
Okay.
And so with radio signals, that's what we're dealing with in this problem. We've got 3 different transmitters, and they're located at 0, Q, and R. And what's going to end up happening here, if we look at it nicely enough, 0 is at the origin.
Hey, wow, that makes things bearable.
Okay. O is at the origin, not 0. O is at the origin. R is 100 miles due north, so R is up here.
Oh, it's on an axis.
And that distance there is 100. Q is 80 miles east, so here's Q, and this distance would be 80 miles.
Okay. I see a right triangle in there. We may need it.
So the LORAN, which stands for Long Range Navigation, that receiver there's a boat out here somewhere. It's not a good boat color. Let me pick a good...
LORAN, I believe, is a sonar system stretched out across the ocean that allows boats and water traffic to help with navigation.
Oh, okay. It's kind of a big deal. So the sloop, that's a word for a boat, I guess.
Yeah,
Gloria is out here, and it's got like receivers and stuff and transmitters so that they can all communicate. And it tells us that the sloop Gloria receives the signal from O, 323.27, that's microseconds.
Wow, that's really short.
Okay, after the signal from R. So it receives this signal 323.27 microseconds after it gets the signal from R, and then it tells us how long between the signal from O to Q. It asks us what's the sloop's bearing and distance from O. And so that's why this is neat, is because if we call this pinging, kind of. Like if you're pinging back and forth between boats and transmitters, then as long as you have enough points, you can have GPS coordinates for anything
It's
you
like
want.
on the submarine movies when you hear that really cool audio noise.
Boing,
Yeah.
boing, boing, that noise.
The
flashing thing. You know what I'm talking about? That's what you were talking about, right?
Totally what I was talking about. But the whole head movement with that was what intrigued me. Okay.
Thanks. Okay.
It could be some special edits later.
One thing that we do need to know is that there are 980 feet per microseconds. That's a mu right there, by the way, in case you're like, what is that?
Greek letter.
Yeah, okay. So that is how fast radio signals travel.
Which is pretty quick.
Yeah. That must be something similar to maybe the speed of sound. Maybe that's the speed of sound, because radio waves... No, radio waves aren't
I don't think
really
they can
sound.
travel as fast as light.
But anyway.
Yeah, here we go.
So what we're basically doing is we're going to put a hyperbola here. Okay, we've got this hyperbola, and I realize those aren't perfectly symmetrical. We've got one hyperbola facing this way, and that's the path the radio signal takes to get to Gloria. And then we've got another radio signal going this way.
How do they figure all this out?
I'm going to guess that they guessed and got it right, and then we're like, oh, look at this
Hey, let's
map.
make a problem.
All right, so what we're trying to do is find the 2 equations for these 2 hyperbolas, and then if we can graph them and find the point of intersection, that's where Gloria is.
Okay.
So, step number 1.
So when the radio wave comes off, then it goes out in that shape.
Yes.
Okay.
So the OR hyperbola that we have, O and R are the foci of that hyperbola.
Right.
And it would have a center halfway, right?
Right, so 50.
Yeah,
0,
at 0, 50. So that's going to be helpful because it's a hyperbola up and down. So we've got y squared would be first.
Right. And then the x just x squared. Yeah.
Right,
So it'll be y
so-
squared minus 50. We just need to figure out what needs to go underneath on the bottom.
And so to do that, to find A, which is this distance right here, we're going to use the microseconds they gave us times the radio signal speed and then change it from feet to miles. Okay, so
Because we have feet per second.
right, we have right now 323.27 microseconds, but we want this to be a distance. So you times it by this.
Because we
This
need to
is
know,
dimensional
we need the actual
analysis.
distance part from the center to a point on the curve.
Right.
And when they gave it to us as a rate of change, then by doing some dimensional analysis, we can eliminate one of those things and get it to where we just have the distance only.
Right.
So use what we know to find what we don't.
Right.
Okay.
So if we work this out like on our calculator, surprisingly enough, we end up with 60 miles, which is just a lovely, that's a lovely,
Well, that's nice. 60's,
really nice.
60's round.
and that actually gives us 2A. That's the length of our axis.
From the whole axis. So
Yeah.
from the vertex of each part of that hyperbola, the one bending around O and the one bending around A, the distance of that major axis is 60.
Right, so that means A would be 30. And
From the 100, or from the 50, right? So you're going to go up 30 and down 30
yes, from 50.
to get your different vertices.
Yes,
Right.
so A is 30, which means we put 30 underneath Y.
Squared.
30 squared underneath Y. And then we need to figure out what B is, but we can do that because we know that the focus here,
We know where that is.
we know, yeah, because this is a length of 100. To get to this focus, so between these is 100. So how far is it from 50? It'd be the center point.
50.
So it'd be 50. So that's C, right?
Yeah.
So we got to do the Pythagorean theorem on
Right.
that.
So we
because
know what
that's
C
our-
is. We know what A is. We just need to know what B is.
So 30 squared plus B squared equals 50 squared. So 50 squared minus 30 squared and square root that is 40. Oh, well, that's a bad way of writing that. B equals 40. So we put 40
B
squared
equals
on the bottom
basically
of this.
2,500 minus 900,
Yes.
which is 1,600. The square root of that is 40.
Okay, and
All right.
so this is our equation, and we can rewrite this with these squared, but we're gonna put it in the calculator anyway,
Right,
so we can
so
do
that's
that
okay.
later. Let's do the other hyperbola. So for our hyperbola that's OQ, that has x first, and our center, if that's 80 all the way across, is at
Center would
40
be
comma
40.
0.
And that would be with the x coordinate, not the y coordinate this time.
So x minus 40 squared, and then we don't need the parentheses there, we just need y
You
squared.
did the same thing.
I
just a
know,
second ago.
right? What's wrong with
I
me?
don't know.
So then to find the 2A part here, we do,
We look at the second rate of change they give us, and we perform dimensional analysis again to get just a distance and lose the rate of change. So, lucky for us, they gave us that key bit of info about how many feet per microsecond.
yes, couldn't do it without that. So if we work that out, then we get 48 miles.
Wow, that's really convenient.
Yeah, it is. Somebody did a good job writing this problem. So
guess
A
so.
equals 24. Actually, that
half-
might
half
be
of that-
rounded because it has a little approximate symbol on
Okay,
it.
that's okay.
A is 24, so on the bottom of this would
24
be
squared.
24 squared. And C in this case is, since it's 80 all the way to our foci,
Right,
and our center is at 40, so that C would be 40.
right. C is 40. Just
Okay.
like in the previous problem, the 50, which we already knew.
And so we do A squared plus B squared.
Jeez, Mr. Altstein.
C. So 40 squared minus 24 squared, square rooted is 32. So B is 32, which gives us 32 squared on the bottom of this.
That too has a long neck. Okay, so the math so far hasn't actually been that bad. The dimensional
Knowing what
analysis
to
is
do
yeah,
is the
knowing how to
issue.
get started would be the most difficult part.
Right.
But now we've got these two equations. What can we do next?
We can graph them. We can, if you have an Inspire, you're lucky because you can just plug them in as is. If you have an 84, you're going to have to solve these for y. So I'll start with the first equation. solving for y, I'll just make that 900. So you'd add the x squared over 1600 to the right side. You'd multiply by 900, then square root, then add 50. So y minus 5 squared equals 900 times x squared over 1600 plus 1. And then square root both sides. So y minus 5 equals plus or minus the square root of 900 x squared divided by 1600 plus 1. And then add 5 over. So y equals 5 plus or minus the square root of 900 x squared over 1600 plus 1. So you'd have to put that in. You can put the plus and the minus, but really we just are concerned with the top one, which I'm guessing would be the positive, but I don't know. So you could test it out. You could type it in once.
Oh, I was
with the
typing.
plus.
Sorry, while you were explaining, I was typing
Yeah,
on an Inspire.
no,
So
no. So you could see if it graphs the right one. We really just need the top one and the right one of these. So the other one, if you just kind of follow actually it's going to be almost completely different since we're trying to get y squared by itself. We'd have to add y squared over, which means we'd have to subtract 1 so that we've got x minus 40 squared. I don't know what 24 squared is off the top of my head.
24 squared is 24 squared.
324. No,
I don't know.
That's not right.
That can't be. I don't feel like that's correct, but you may be right.
No, it's not. I also don't know what 32 squared is off the top of my head, so I'm just going to leave them be. So you'd multiply by 32 squared?
We're wanting first quadrant, correct?
Yes.
Okay.
So you multiply by 30.
Ooh, these are really big.
I did not. That one's supposed to be on the other side.
We go to we're going up to 100
I'm
on X,
subtracting
right?
1 over. Okay.
So let's go up to.
So now I would multiply by 32 squared on both sides and then square root. So
I found a point of intersection.
and so once you have it graphed and they should intersect, then you can find the point of intersection using your calculator, the tools you have there. Y equals plus or minus 32 squared times x minus 4 squared divided by 24 squared minus 1. Good thing we just have to put that in the calculator, not actually figure it out.
I got 180. I got 187 and 193. 187.085 and 193.485.
Well, that sounds reasonable to me. Does it sound reasonable to you?
Yeah, and hey, it matches the book.
Okay, so to find the bearing and direction for this,
The bearing and direction?
the bearing you use, this is taking it back a ways, you use inverse tangent of y over x.
Because we've got to get the angle of measure from 0, so we got to actually work from what we know already with our trig stuff, okay? So this is going to give us the angle off of the x-axis.
And once we have that angle, we have to do 90 minus that.
Right.
Because the bearing starts from up here. Our calculator's going to give us this angle.
Right.
We want the bearing, which is this angle,
Right.
from north. And so if you do that, 90 minus inverse tangent of that fraction.
Right. And so carry that through. Try to keep your answer in there. Try not to round if possible.
Right. You should get 44.04 degrees. That's our bearing. The distance from 0 to Q, that's a right. Hey, you mentioned a right triangle.
Oh my
earlier.
gosh, I didn't I? Wow,
There's
there
a
it
right
is.
triangle
There's a
there
right triangle.
with sides 187 and 193, so we just do the Pythagorean theorem on that. So
to get the hypotenuse.
187 squared plus 193 squared square rooted gives us 269.15, and we're in miles because we converted earlier to get into miles.
Wow, that's a lot.
That's quite a problem.
That's a problem.
That's, whew.
But there you go. There's not getting lost on the ocean right there.
Yes.